Hello all, welcome to part 3 of module 6 in the Security Tube Python Scripting Expert course and certification. In this video, we will look at how you can disassemble code using the Pydasm module. So let's get started. Here is our Windows 7 professional machine in which let's go ahead and first start an idle terminal on which we can probably type out all our commands, etc. Fantastic. Now let's open up Immunity Debugger. And this is just in case you want to try out interesting instructions. Let's just go down here. Let's open up Notepad. Come to what I mean in just a second. Let's go ahead and basically increase the font size. Okay, fantastic. So before we begin, installing Pydasm is a bit of an exercise in itself. And for people who've done it, you know what I mean. If you haven't, I think it's probably a worthwhile exercise to install Pydasm on Windows 7 and to use Python 2.7, right? So first do this, because without this you would not be able to try out anything, because Pydasm does not shift with the reference implementation of Python. It needs to be installed separately. Now, what is Pydasm? Well, the whole idea is that we need some way to disassemble all those binary instructions going into the processor into its assembly language equivalent. Now, there is a C library called libdasm, which can actually be used to disassemble these instructions, and Pydasm is basically the Python bindings for the same library. The most fantastic part is, with Pydasm, your programs can disassemble binary, look at instruction sets, take decisions, and do a ton of things, which, as you can imagine, is very critical when you want to go ahead and analyze any binary sample. So let's see how we can do this. Let's go back here and let me import Pydasm. Please note, you will need to install Pydasm yourself first. The reference implementation does not ship with it. So if you're trying to import it without installing it, this is the point where you're going to get an error where it would not find the module. Now, the key thing here of disassembling instructions is to feed in the raw hex code of the instruction equivalent. Now let's go ahead and do this. Let's say instruction equals Pydasm dot, and then what we basically have here is get instruction. Now the input is basically the instruction itself. So let's feed in an example instruction 50, and what this is going to be the hex, kind of equivalent of the final machine level code executed by your processor. And then we need to give it the mode, and in this case it's going to be 32-bit. So we have mode underscore 32. Now, as you can see, this will go ahead and give us an instruction instance. Now, in order to disassemble this, here is what we're going to do. We'll say instruction dot get instruction. Actually, we just need to call Pydasm, not instruction. My mistake. Pydasm dot get instruction string, then feed the instruction object which we have, and after that we need to basically tell it the format in which to disassemble. So the format is going to be Intel disassembly, and once we run this, my mistake, it's going to be Pydasm. And once we run this, you notice that basically 50 is equivalent to push EAX. Fantastic. Now we could try slightly more complicated instructions as well. So let's say instead of this, we could try out, and I don't know if any of you can already guess what this instruction is. Would really be amazing if you can. And this is basically test EAX, one of the very common instructions which you may have. Now note that if you like AT&T instructions, you could just change the format to format underscore ATT, and this would give this to you in AT&T mode. Now you can disassemble basically larger instructions as well. So as an example, let's say a slightly more larger instruction. Okay, let's use this one, which is choose food. Okay, here goes. Now if we try to disassemble, this is return the value 4, right? So this is how it is possible to disassemble instructions very simply, extremely fast with Pydasm. Now actually, this instruction object as well as Pydasm has a ton of other interesting things which you can figure out about your disassembly. Probably leave you with looking at everything they have to offer. Right? So you have different instruction types, which is for a given instruction you can figure out the type, the different modes which are possible, 16 and 32 in this case, and then of course finally the different methods which are available to you. Now similarly, you could look at all the interesting stuff available in the instruction object. Right? So you have a bunch of interesting stuff. OP1 and OP2, OP3 is basically operands. You have stuff like the length, the type, which I would encourage you to explore. Now in this video, basically I wanted to show how simple it is to do 32-bit disassembly using Pydasm. Let's go back to our slides and look at the exercise I have for you. So the exercise is to create a simple Python script which can disassemble the first 200 bytes of executable code of any PE file which can be fed as input, right? And what I want to see as output is the hex bytes, which is the actual binary. And on the right hand side of the hex bytes, similar to as you would see in something like your immunity debugger, basically what I want to see is on the left hand side is the actual hex equivalent of the instruction, while on the right hand side I would want to see the disassembly, right? The second exercise is even more interesting. I think all of us have used exploits where we see all of that interesting looking shellcode, you know, all those numbers which almost makes you feel like Matrix, Neo from Matrix. So the second exercise is generate shellcode without any form of encoding, that is, for a Windows bind shell, and then use Pydasm to disassemble it. Now the reason I tell you not to use any encoding is that if you encode the shellcode, then basically you would first have to decode it, and then you may have to end up getting the final equivalent from the disassembly of the decoded shellcode. So keep it simple, create simple shellcode, Windows bind shell, and use Pydasm to disassemble it. That's all for this video. Thank you very much for watching, and if you have any questions, please post them in the student forums and we will get back to you as soon as possible. Thank you and have a great day ahead.